Again, greetings to our respective listeners. Our topic is about engineering estimate, particularly to civil engineering construction. It is important to be knowledgeable estimate because this gives us the information that also gives us the project cost, including the materials and manpower needed. It helps us to allot budget for certain construction items and serves as a basis for the sequence of activities. Estimate involves computation, meaning you get involved with numbers. Alongside with it, you attempt to visualize construction process of starting to finishing the project. It also takes imagination and knowledge so you can have better estimation data output. Estimates provide detailed description of the project and the cost involved to it. It helps the contractor and client get an idea about costing and the plan accordingly to complete the project efficiently. Construction estimating techniques helps us to ensure that the contractor does not lose money and the client does not overpay. Estimate is also interconnected with risk mitigation. Say, not all plans are perfect, right? When it comes to actual execution, especially, and unforeseen circumstances takes place, making the task unfeasible on time and budget. So proper estimating allows you to account for both expected and unforeseen expenditures, safeguarding profit margins and safeguarding the budget. However, not all estimates are also perfect. Uh, as much as possible, we calculate to bring out accuracy and approximations that will not cause high financial sacrifice and loss to both the client and contractor. Before we jump on the quantity computations, let's discuss first some definition of terms and other important matters for clarity purposes. Estimate is a roughly calculated approximation of what the project will cost. There are two types. We have the detailed estimate and rough estimate. In the event your client asks you to how much would it cost for an 8 by 10 meters fully furnished, say bungalow building, you do a rough estimate like for per area. Say per square meter, it costs 30,000 pesos. Then therefore, 8 times 10, which is equivalent to 80 square meters area of the building, we come with assumption of 2.4 million pesos in total. But for some cases, if we try detailed estimate, the cost might experience decrease, but it takes time to compute because you go into details as per proposed plans of the building. However, detailed estimate gives us more accurate to near reality projected costing. In rough estimate, we just give the rough idea of cost of structure from previous experience and knowledge and neighborhood structures. On the other hand, in detailed estimate, we give the details, specifications, and quantity of each and every material. Speaking of cost, I hope you won't interchange it to the definition of price. The key difference between cost and price is the amount of expenditure you incurred or on materials, labor, and other related activities. In contrast, price refers to the amount that the supplier charges for providing you the goods and services. However, price and cost both have same meaning, the amount of money you pay for something or that something that costs. But the main difference again is the perspective. Price is generally used to refer to the amount of money that a supplier or seller is asking for something. And cost generally refers to the amount of money that you will spend rather than the price of the product or material needed. Bill of materials or BOM is a structured list identifying all materials, components, and subcomponents required to construct an activity as well as procuring and using the material. Specification or what we call the spec as per Autodesk definition. It means the detail of work and workmanship required for each construction project. It is usually a written document describing the scope of work, any materials that are to be used, methods of installation, and the quality of workmanship under contract. Program of works, sometimes equivalent to the bill of quantities. This represents the project information, the basic information like the title, location, the projected budget, allotted budget, the duration, how many calendar days, including the list of summarized quantity of activities, and as per material and manpower. Manpower, speaking, is the working force that is committed to building constructions, such as planning, erecting, and modeling the building. Say, the engineer in charge, the foreman, laborers, plumbers, electrician, mason, carpenter. These are the key role players in manpower. Sometimes we also include here the machines and tools to be used, such as the rebar benders, cutters, jackhammers, vibratory roller, plate compactor, concrete mixer, transit mixer, portable lift or the portalift, backhoe, excavator, and other related equipment. Schedule. Schedule is a timeline for every task and event in a construction project. It is a tool used by contractors to track the progress of a project. For some instance, we also include here the bar chart, S-curve, and even per CPM or the critical path method to look out for the priority projects. However, in modern techniques nowadays, we use the PDM or the predecessor diagram method, which is more informative and easy to evaluate. In the estimating profession, we also have three categories who does the job. As you apply for work, especially abroad, you might encounter job titles like cost engineer and quantity surveyor. Cost engineer originated from United States, and the term quantity surveyor came from UK or the United Kingdom. Civil engineers tend to have the ability to estimate, thus making them play the role of being a cost engineer and sometimes value engineer. But when it comes to the title quantity surveyor, to become certified for the title, or if you are wanting to work abroad for it, it takes years of experience. The least experience would be like 3 years, and you have to earn bachelor's degree in quantity surveying and round of examinations plus interview to get real certified. Certified quantity surveyors refers to a person who is a holder of a certificate of registration and a valid professional license issued by the Board of Quantity Surveying and the Professional Regulation Commission, who is legally qualified to practice quantity surveying in the Philippines. Anyway, it is your option. If you want to enroll for schooling, it's like a masteral degree, 2 years as far as I know. And it is offered at MAPUA, PIBE, or the Philippine Institute of Built Environment, or PIBE, and PICQS, or the Philippine Institute of Certified Quantity Surveyors, and sometimes it is offered at PCA, or the Philippine Constructors Association. It's like an equivalent group of professionals for civil engineers, but more quantity surveyors. It's like equivalent group of professionals of CE, but more focused on quantity surveying or broader estimate field. This is an option if you want to grow yourself in the estimating profession. Moving on, let's define first the limitations of the following key players of estimates. We have first the cost engineer. The cost engineer or cost estimation engineer estimates cost for engineering projects based on analysis of project technical requirements. Cost engineers collects and analyze all project costs, including raw materials, labor, equipment, and tooling to ensure estimates are accurate. Cost engineers also update the cost as necessary based on new information and project scope changes. Additionally, cost estimation engineer requires interference with project management, engineering, and procurement departments. Next, we have the quantity surveyors. Cost engineering and quantity surveying have similar and highly overlapping functions. Quantity surveying relates more to building design and construction, while cost engineering relates more to engineering projects and processes. However, cost engineers and quantity surveyors commonly work in both areas. Well, they both mean pretty the same thing. But it's all about professional name and the functional name. More so, area of exposure and expertise. Every professional quantity surveyor is a cost engineer by function, though not all cost engineers have quantity surveying background. As I mentioned earlier, cost engineer and estimating engineer are professions names given in the US for post and pre-contract phase quantity surveying. Under the UK system, United Kingdom system, both the roles are handled by quantity surveyors. In short, US, in the UK, you need to know both pre and post contract work on the cost aspect. Furthermore, QS is a distinct profession by itself. In the UK, whereas in the US, professional engineers turn cost and estimating engineers with few years of experience. Value engineering, well, it was coined and introduced during World War II via manufacturing industry. General Electric was dealing with labor shortages and lack of materials and limited availability of components needed to fulfill contracts. This real-life challenge forced Lawrence Miles and his partner Harry Ehrlicher of General Electric to look for alternatives to how they had traditionally designed, sourced, and manufactured their products. These two manufacturing leaders learned that material and process changes can both reduce cost and produce a better final product. Miles and Ehrlicher coined this review and evaluation process as value analysis. Today, value analysis has been transformed into value engineering and has become a key component of every estimator's toolkit. In construction projects, value engineering can be used at any phase of construction project to ensure the best possible value with the lowest cost to resources, budget, scheduling, and the project success. The main difference of quantity surveyor or QS among these two is that to be certified, you needed a separate degree aside from being a CE. And quantity surveying has more scope compared to cost engineering and value engineering. You can perform both or rather go extra work analysis before, during, and after the construction process. But in the event where financial budget is at risk or your schedule is intending to go behind duration, quantity surveyors attend to these matters. Value engineering is more on analysis of finding optimum project cost, but not sacrificing the functionality or quality of the item or items. While cost engineering performs quantity takeoffs as per scope of works and changes. In addition, estimators must also be familiar with structure categories they are working on, because during estimate proper, for example, concrete works, multiplying factors for concrete in buildings is not as the same as roads. It is also important to categorize of which structure we are estimating for more organized work purposes. The main difference between horizontal and vertical construction is predominantly in the spatial context. Space. Is the project spanning wide or is it growing tall? There are obvious differences. Another differentiator in this type of construction project is the funding. Vertical construction leans primarily on the private sector, whereas horizontal relies on government, state, and municipal funding. So we have the vertical structure and the horizontal. To establish which category your project falls to with its special reference or the space. Horizontal construction is typically wider and lower to the ground, while vertical construction is higher. Vertical structures are structures that are going tall. A skyscraper is an example of vertical structure, and as is a high-rise building. Typically, a high-rise building is considered to be more than 7 to 10 stories, or 23 to 30 meters. Vertical construction primarily consists of projects that are built vertically and rely heavily on design by an architect. But we also do that as civil engineers, but there are limits. Examples of vertical construction projects, we have the buildings like skyscraper, offices, apartment buildings, museum, parking areas, subsurface or structured facilities, and building foundations and site works. Horizontal construction involves structures that are longer and wider than they are tall. Some examples of heavy civil construction projects include, but are not limited to, infrastructure and transit, roads, railways, and bridges. We also have the power and communications like transmission facilities, electric lines, fiber optics, and we have the subterranean pipelines, sewer, water lines. Moving on, there are several applications that you can use on your estimate, especially when you are on a certain foreign company. Some require using the cost X or plan suite, contractor foreman software, on-screen takeoff software. But what's more prevalent is using the Primavera MS project or your customized spreadsheet template using Microsoft Office, Excel. What makes the MS Excel convenient to use is that you can create your own template. You can use it on your private projects and you can update factors and you can automate the links and formula, add finite worksheets, insert your own charts and diagram schedules. It is more handy and there is total freedom because you are the creator of your own template. Unlike Primavera, MS Project, and other applications, there are limits and urges you to encode manually the data so that you can compute the project cost, manpower, equipment, and projected calendar days. Now for the formula, we have the basic computations such as area and volume. Usually, the unit for area is square meters and volume to cubic meters. We apply area computation usually on ceiling works, carpentry, cabinets, drywall partitions, glass works, formworks, roofing, painting, and masonry works, especially tile. For volume, We apply it to earthworks such as excavation, backfill, gravel bedding, and regular fill. Included here are reinforced concrete footing, columns, beams, slab, reinforced concrete stair, and other items that involve pouring of concrete. For plumbing works, we get the sum of all linear length of needed pipes, either sanitary or water line. And we manually analyze and count the required fittings like T, elbow, coupling, or Y, and the plumbing fixtures like the water closet, bidet, urinal, sink, lavatory, and shower. As for the components, one must know the parts of what kind of structure you are estimating. A component is a constituent part of a building. Say, for example, the basic components of a building structure are the foundation, floors, walls, beams, columns, roof, and stair. These elements serve the purpose of supporting, enclosing, and protecting the building structures, and these are essentially needed to reflect on your estimate. Why you should be familiar with the components is that this is to avoid redundancy or missing quantity in your computation. If you are not aware or not familiar with what you are estimating, you expect errors, maybe inadequate number of pieces of rebars or bags of Portland cement. These small errors might give you unwanted risk and might give effect to the productivity during actual implementation. Instead of gaining, you might be sacrificing time and money. So you need to explore the parts of the structure and know how to organize them. Shown here are the basic components of a building. The parts below usually consist of the foundation, grade beam or tie beam, then ground floor slab. Succeeding floors above, we visibly see the columns ascending like the reinforced concrete beams, suspended slab masonry works, especially the concrete hollow blocks, walls, and tiles for cladding stones. We also have the roofing, which is at the top. We also have the doors and windows, the accessories, the plumbing, electrical, and then fully furnished with painting. Note here, in construction buildings, we we include first earthworks, especially structure excavation, and also establishment of bunkhouse, project board or the billboard, or information board consisting of building permit, meaning you are allowed to operate. And as much as possible, we put protective or temporary fence for safety purposes. For the roads, we have the basic subgrade, subbase, the base, and the topping. The topping could be made of asphalt or concrete. Road designs vary as per road engineer's design, as per plan, and their basis is more on the DPWH Blue Book. Bridge construction comes in different kinds of structure, but basically we have the abutment, foundation, girders, pier, parapet, and slab deck. Actually, bridges has two parts. Have two parts. The substructure components span below from the slab soffit down to the foundation, while the superstructure part is from the slab ascending to the frames above, or what we call the link wires or rods. As for the flood control, shown here is the reinforced wall with basic parts pile cap with sheet pile, then sloping above is the reinforced wall. Other kinds of flood control include mattress, bastions, or riprap, stone masonry, and rubble masonry. Now, say you are already familiar with the components. Here are some tips before we end this short introductory estimates. One of the most important thing is that you should know how to read plans. Know the specifications and even the details. The next, try to imagine how you're going to execute the activities. List the materials and possible manpower needed, and be aware of the sequence of work to be done. In estimating, be familiar also with the multiplying factors, like if you are computing for the number of CHB walls, you compute for the area multiplied by the magic number 12. Then you can get number of CHP pieces to be ordered. Aside from calculating the required number, be aware of the market availability and the price too. Organize and be able to create your own format in the event your company does not have their own estimating software. You can use MS Office, but you should know how to input data and manipulate quantity takeoff. Know how to categorize which item would fall. Like, for example, we have reinforced concrete isolated footing, column, beam, slab, RC wall footing. These are under concrete works. Then under masonry works, we have the CHB walls, tile works, plastering, and stone cladding. Be knowledgeable with the civil works, structure components, methods of installation, basic formulas for quantity computation, and the possible risks, and one should know or like anticipate or foresee the possible risk and immediate solutions. You must anticipate the unwanted factors that might affect the productivity of work to be done. That's why for some cases, there are contingencies and budgetary offset needed to include in your estimate. So, yeah. But again, estimates are not always perfect, but we project the most near to reality cost of our project. Especially in actual implementation, it is inevitable that there would be changes. So what we do is be patient and do the job, adjust and recalculate the data and manipulate other factors you must consider. That's all for this short webinar. Hoping we could discuss more on our next session. I will be using MS Excel and sharing you some essential process and creation of your own formats so you could have more organized estimating sheets. Actual computations and estimate will take place on that seminar. So as much as possible, you must be prepared, especially with the formulas, and have yourself kind of orientation in using Microsoft Excel. Again, thank you for listening.